Always a fun one. All right. Today we are going to look at semicircles, and that will finish out that whole section with the, I want to say that was 3-2. That included everything with the circles and the symmetry and the center and radius. So we had our symmetry, we had our intercepts, we had our circles, and our semicircles. That's all section 2. Huh?
Oh, you're Madara from Hercules.
I always,
There's a crime for rotten judgment.
I always say her name wrong.
Megara or Megara.
I keep thinking her name is Megan.
It's not Megan. That would be the scary movie. Ish. I don't know. I've heard it's a horror movie.
I don't know. I don't watch horror movies.
I don't do horror movies. If I watch a movie, I want to be happy.
Yeah.
Is more like funny or
Yeah. That's still not my vibe. I'm more of like a bubblegum kind of vibe.
Mm-hmm.
Cheesy happy. And one of the rare brunettes for Megara. Because it's pretty much Belle and Meg. And that's about it. And Mother Gothel. All right, so we're going to work today with semicircles.
Have you seen the performing arts teachers?
I did. Or at least I saw Mr. Rubel, and I couldn't tell who it was because I saw them from behind, but Maleficent.
That's the new band teacher.
Okay.
And then Stall,
That's R squared.
he got a full like Ursula costume.
Nice.
And then
To be fair, I saw him come in and he was just wearing like normal
Yeah.
work clothes. So I was
Yeah.
like, wait, but
he
they
like,
also have access to the costume closet here, and I'm like, that's
Yeah.
cheating.
but I think he bought it because we did not. I don't think we used. I mean, did we use that for Ursula?
I don't know.
I don't remember.
I was gonna say,
like the actual skirt that she would like tie the circles.
Oh yeah, I get it.
all right. So semicircles are half circles. We're gonna find a few different ways we can find them. Because we have these pieces that are squared, whenever we're finding semicircles, we're gonna have to do a little bit of solving. So if we're thinking about upper or lower semicircles, because we're gonna have a couple different ways we can do that, meaning I either wanna have a semicircle that's a top half or a semicircle that is a lower half. So either one of these, if I wanna cut the circle in half, that means we need to solve for y. So we'll get like our y equals, and at some point we're gonna have to do a square root. And typically when we do that, we put our plus or minus square root of blah, 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 whatever. Well, if I want to have the top half semicircle, that would be when it has a plus. If I want the bottom half semicircle, that would be if it has a minus. So to get the upper and lower, and kind of an easy way to remember that is, well, this guy's a function, so it's a y equals, and that guy's a function, so it would be a y equals. These guys make almost parabola looking things. The positive one is the top, the negative one is the bottom. Also, that's where the positive y values are versus the negative y values. So positive and negatives. So if I want to then get left and right semicircles, a little bit different, meaning I want to cut my circle like this. This would be when we would solve it, instead of being for y, we would solve for x. And we get an x equals whatever thing we have square rooted.
What's in the square root?
It's going to be like, if we were to solve this, we would usually have numbers in here, so it will be, like, we're going to work through, I promise. It's just a matter of which side is going to have the positive, which side is going to have the negative. So with our x's, we here wind up with non-functions. They're not functions, but we get an x equals. And it's very much like how we have on the number line. Positive values are going to give us our right-hand side. Negative values are going to give us our left-hand side. So if we look at our right semicircle, is going to be our positive square root. The left semicircle would come from the negative. So what's going to happen is we're oftentimes going to be given an equation for a circle, or given enough information to make an equation for a circle, and asked to find a semicircle, whether it's the left and right, whether it's the top and bottom. Sometimes we'll be asked to find all four. But each semicircle will have its own equation. And we're going to practice this because I know it just felt a little Greek, especially when we don't have any information inside the semicircles. So the first one we're going to look at is a very basic circle. We're going to have x squared plus y squared equals 81. And we're asked to find our upper and lower semicircles. Now on this one we could actually find all four. It's not awful, but it's not the super awesomest. Huh? As you say, we're going to have the whole thing there. So if we want to get upper and lower semicircles, so top and bottom, that means we want to get this to be a y equals. Top and bottom is y equals, because my y's are going to split into positive portion or negative portion. So what do I do to this equation over here to start working towards getting this to be a y equals? Subtract x squared. So we're going to minus x squared from both sides. And we're going to have our y squared equals, and you can put it as negative x squared plus 81, or we can put 81 minus x squared, and that is 100% valid. And then we want to get our y equals. So to get y all by itself, we're going to square root both sides. Now typically when we square root both sides of an equation, that's when we put in our plus or minus. The square root of 81 minus x squared. Yes, dear. Don't like to graph the semicircles. Honestly, it's easiest to go from the circle and just take right or left from it, because we would find our center and our radius and just draw half the circle. So if we want to get our upper semicircle, that's when we're going to take our positive square root. So our upper semicircle is going to come from our y equals the square root of 81 minus x squared. And if we wanted to think about sketching this, we know that the center of this circle is going to be where? Where's the center? 0, 0. What's our radius? 9.
Oh, yeah.
So it would go from 9 and negative 9, positive 9, and negative 9. So this would be our whole circle. So if we just wanted the upper semicircle, that would just be, I wanted that slightly bigger. It would just be this top part. Nope. It's not a perfect square. It's a difference of squares. Like you could get 9 plus x, 9 minus x, but that doesn't help me square root it. Semicircles are going to have radicals in it. There's not really anything we can do to get around it. So our lower semicircle is a very similar vibe. For the bottom half, it would be that we had our y equals the exact same radical. It's just going to be negative square root of 81 minus x squared. And that would be this guy down here. So the semicircle is, honestly, if we're going to graph it, we're going to put it back as a circle. So this one's not awful to find them in because there's not a whole lot of extra bits. Questions on this first one? That's it. Let's do another one. Now we're going to do a left and right semicircle. So here we have x minus 3 squared and y minus 5 squared equals 4. So from here we could sketch our circle if we need to. We don't need to really like sketch out the semicircle. If you want to, you can, but let's say I'm just double checking on the homework. I don't think. Oh yeah. Okay, so if we want to find our left and right semicircles, that means I want to get to an x equals. Because if we're looking for left or right, I want to get down to x equals. So what do I need to do to get this equation down to an x equals? I can't square root both sides right now, because if I square root both sides with this being added here,
Minus y.
so minus that chunk. Let's get rid of the y from over here, because I would like to be able to square root this piece to get rid of the square, but I got to get rid of this piece first. Minus y minus 5 squared from both sides. So we're going to have our x minus 3 squared equals this hot mess. 4 minus y minus 5 squared. Now, trying to get my x by itself, now I can square root both sides. And when we square root both sides, we're going to have our x minus 3 equals our positive or negative square root of that hot mess. 4 minus y minus 5 squared. Plus 3. Because I need my x by itself. So we're going to add the 3 to both sides. And we're going to have that our x equals kind of our generic form. Like that. So if we're just solving to get an x equals, we wind up with 3 plus or minus the square root of 4 minus the quantity y minus 5 squared. We don't need to multiply that out. We're not going to be able to find a nicer value for that. It's going to be incredibly uncommon. They're going to be icky looking, but that's what they do. So if I want to get my right semicircle, that's going to be when we use the plus. So we're going to get our right semicircle by having our x equals 3 plus the square root of 4 minus y minus 5 squared. That's where the positive values are for x. X's are positive to the right. So then to get our left, we'll have our x equals 3 minus the square root of 4 y minus 5 squared.
This was the entire equation. Why on the last problem it was just 9 instead of like the entirety of the rest?
Because on the last one, we didn't have any other pieces added in here. We didn't have x plus 2 or y minus 3 or any of those other pieces in here. So when we subtracted the x squared, we would have been subtracting our x minus 2 squared or whatever it would have been. If y hasn't been added, we're going to have to just add it to both sides. So if we're centered at 0, 0, it's going to be the tidiest the equation could look. If we're not centered at 0, 0, it can look like a hot mess.
Wouldn't it be 9 minus x?
Since there's that subtraction inside, we can't, like, that only works if we're multiplying our radicands, is when we can split them apart to simplify. Since it's being subtracted, it doesn't actually work. So if we could factor it into perfect squares, then we could simplify it. But that's not going to give us a semicircle. It won't simplify into perfect squares. They're just ugly looking. Okay. So the other way we're going to see questions like this on the homework is sometimes they will give us an equation for a semicircle for us to look at or to kind of sketch or see what they look like. And I'm going to just kind of write one for us. If we think about x equals negative square root of, let's see, 36 minus y plus 1. There we go, squared. So if they give us something like this, and we're asked to describe what it looks like, or sketch it, first things first, is this a left semicircle or a right semicircle? Left. So that one's a left semicircle because my x equals the negative square root. If I want to make this back to being my circle kind of equation, what would I need to do? Or how could I figure out like where the center is, where the radius is? Square both sides. That's going to give me an x squared equals our 36 minus our y plus 1 squared. If I square both sides, it gets rid of the negative and the square root. Because all those are for us to tell me we're looking at the left semicircle. So to get this back into like our circle form, add this guy back to the other side. And then we'll be exactly into how we're normally used to seeing our circles. So we'd have our x squared plus our y plus 1 squared equals 36. So where is our center? 0, negative 1. What is our radius? 6. So if we wanted to sketch this semicircle, we know our center is at 0, negative 1. We'd have a radius of 6. And it would be the left side. 6. That would work for me. That's the sketch. It does not have to be perfect. You don't have to use a grid. Whenever we're sketching, you can just kind of label things as you need. If you want to figure out this point, this would be at 0, 5. And this one would be 0, negative 7. It's not the 6. This was based off my center. So my center being 0, negative 1, x is 0, y is negative 1. This is just my radius. So everything else in there should be stuff we've worked with before. We may have to find midpoints on things. We might have to find distance on things. We might have to test radius for things. All that kind of jazz. But so our midpoints, our distance, those things all come into play too. But we're looking at our circles, semicircles, and all that jazz. Questions on this stuff? Oh yeah, that's if you counted up 6 from our center, with this being our 0, negative 1. So 1, 2, 3, 4, 5, 6 would put us up at 5. And this guy is our center. Okay. Is that enough? Questions on this one? Okay, because that is the end of 3-2. That was all we had left in 3-2. 3-2 covers a lot. It had all of our symmetries. It had the x and y intercepts testing again. Had our circles, completing the square to find the circle's center, and the semicircles. So a lot of stuff. Which is why we're trying to not floor it through, but there's a lot of stuff. 3-3 has, admittedly, significantly less stuff, and it's all things we've worked with before. So 3-3 shall be very, very familiar because 3-3 has everything to do with lines.
Oh, yay.
We've worked with lines a billion times. Very, very familiar. So just as a reminder of some of our forms, we've got our slope-intercept form, our point-slope form, our general form. I don't know why it has so much space after equations of line. I don't actually have a definition for it. We know our equations. Our slope-intercept form we've worked with before. That's our y equals mx plus b. and our point slope form. We've talked about that one before. It's our y minus y1, mx minus x1. Both of those have m in them. They're the same piece. For both of those, our m is our slope, how it's changing, and it is the same no matter which of these you're using. This one is going through our y-intercept, that slope-intercept form. The b is our y-intercept. And on this one, it goes through absolutely any point on the line. So it's of that structure x1, y1. That is any point on the line. This is for any point on the line, x1, y1. So the x and y that don't have the little numbers are still there in your equation. The ones that have the little numbers, we plug in with numbers. And then our standard form or our general form is the one that looks very different. That's when we have our, changing colors again, green. That's our ax plus by equals c. This one has no slope. Slope is not a part of it. When we are looking at general form or standard form, our a should always be a positive value. This will always be a positive whole number. B can be negative.
You slow down.
Yep. I'm also just going to give you guys time to write this whole thing. Absolutely valid. So B can be negative, C can be negative, A needs to be a positive whole number. We do want whole numbers for everybody. So our standard form or our general form should not be fractiony or decimally or anything gross like that. We're going to do a couple of sketches of lines. So I'm going to cut you guys out some graphs. I'm going to do 3 lines on each graph. If you want to do separate graphs, totally valid. If you want to economize and just do 3 lines on one graph, that's totally fine.
Miss B, we need another graph.
I'm so good at counting. That's a math teacher or something.
Ooh, I didn't see your name.
So did
I love it. It's so pretty.
I kept it neutral so it didn't clash with any of the multicolored outfits. Tomorrow is my most normal of the days.
To be
Because I'm
honest,
twinning with a friend of mine who's not as extra as me.
to be honest, I usually go with like a purple, red, black, or silver, or a combination of thereof.
Yeah.
And this time I went with like a blue. I wanted it to be more sea blue, but it looks more royal blue.
It's definitely TARDIS blue.
Yeah.
All right.
Fun times, but I was so upset because I saw blue that would have been perfect, but it's gel and I haven't gotten the stuff yet for it.
That makes a difference.
It sucks.
All right. So what we're given here, and this will happen sometimes in the homework because they want us to sketch. They've given us kind of part of an equation here. They've told us we're doing y equals mx, no b. So if we're looking at y equals mx and we're trying to sketch all 3 of these lines, what they're really wanting us to graph is y equals 4x. So where am I going to start? What's my first point? 0. It's not anything that has a slope of 4. It's got to be the one that does not have a plus b. Going through our 0, 0. So it's going to go through 0. And if we have a slope of 4, how am I getting my next point? Up 4, right 1. Up 4, right 1. Or I could go down 4, left 1. That would give me the very same line. I can go either direction. You do want to use a straight edge of some sort whenever we're graphing a line. If you need rulers, I have tons over here. You could also use the edge of a notebook. You can use the edge of a ID. You can use the edge of your calculator. Use the edge of your phone. Whatever you want. But we should get a line.
Do you have colored pencils?
Yes. Yeah. If you ever need rulers, colored pencils, highlighters, anything like that, let me know. I have tons and tons of them. You get several of the same colors, but it gives you varieties. So this line's going to look like this.
I took so much time to organize this last week.
Yeah. It's okay. It's not far away from it. Mostly that just came from me flooping them down. So I'm going to do all 3 of these on the same graph. Like, it's lines. I don't feel like I need to change it all that much. I'm going to make sure that's a vastly different color. So let's do purple. So this one I'm going to do with my y equals minus 2x. Same thing. Here I don't have a b value. So again, I'm going to be going through that 0, 0, but I'm making a new line here that has a slope of -2. How do I move with a slope of -2? Down 2, right 1. Down 2, right 1. Absolutely valid. Or I could go, and I think I heard it, but it was just, everything was kind of overlapping, so it wasn't super clear. So everyone was slightly hesitant. I could go up 2, left 1. Absolutely valid. As long as I switch both arrows, I can go the other way. The more points you have, the easier it is to connect them up into a straight line. Technically, it only takes 2 points to make a line, but the more points you have, the easier it is to get them to line up. So when we plot up our -2, it should look like this. We get arrows on both ends. And we're going to have this one. Very same vibe. If I have an m of 1/2, in this question, we're trying to do our 1/2 x. They haven't given me a b value here. All of these are going through 0. So with our slope of 1/2, how do I get my next point? Yep, up 1, right 2. Up 1, right 2. Up 1, right 2. Rise over run. And again, I could switch and go the other way, down 1 and left 2. As long as I switch both, we're still cool. The pink one?
Yeah.
That's the y equals 1/2 x. So again, we are starting at our 0.
Mm-hmm.
Up 1 over 2.
Okay.
Rise over run. So if they don't tell us the y-intercept, this is what they're intending. And there's one like that on the homework. It would be number 14. It's very much like this on the homework for the 3. questions on these three? Because I mean, we've worked with lines. We can do lines. Totally cool.
Are we about to do another thing?
Yes, we're gonna do 2 more little graphy graphs like this.
Okay, give me a thing.
That's all good. Sometimes they won't give us a point to go through. They're just gonna give us our y equals mx for these values of m's. Sometimes they'll give us more information. Like they'll say, for this point, 3, 1, use these m's. So you can write your equation as point slope form. You don't have to. You could put these into a slope intercept form if you're feeling real froggy, but you don't have to. All we need to do is sketch these out. We could put them in our point slope form. We have enough information. We're given a point. We're given a slope. I could write an equation, but we don't have to. All we know is that these are all going to go through the point 3, 1. So the first thing I need to do is to plot the point 3, 1. That's the point P. And I'm just going to bounce real quick. I'm going to do this one. If I wanted to move with a slope of 2, again, I could write this in my point slope form. My y minus 1 equals our 2 x minus 3. I could write this in my point slope form. I've got a point, I've got a slope. You don't have to write the equation, but it's there. We could do it. How do I move with a slope of 2? Up to, right, 1. But this time I'm not starting from 0, 0. Starting from here. So I'm going to go up to, right, 1. Except I did that one blue. I can go from this point. You know it's supposed to go through this point here with my slope of 2. So I can go up to right 1. And then again, up to right 1. Up to right 1. You don't have to start at the y-intercept. We can start at any point we know. And the same thing, I could go the other way. I could go down to left 1. You don't have to fill the page with the dots. The more dots you have, the easier it is to connect them up. But I honestly trust you guys to draw lines, hopefully. And we should get a line that looks like this. So through a point with a slope. If I wanted to make this equation in slope-intercept form, I could find my y-intercept. I could also take my point-slope form and multiply it out. You don't have to write the equations. I just wanted to talk through it there for a second. So now I'm going to do that one I kind of skipped over and just ignored saying anything about. Because we have one here that says our m is 0. How do I move with a slope of 0? More specific. Horizontal line. You can think of that as up 0 over 1. Up 0 over 1. Up 0 over 1. Whenever we have a slope of 0, that's our horizontal lines. So our line on this one is going to be just a straight horizontal line. If our slope is undefined, that's when we're going to have our vertical line, because it's not a slope. It would be 1 over 0. So up 1, right 0. So a slope that's undefined is a vertical line. A slope that is 0 is a horizontal line. And then our third one up here, we've got our slope of negative 1/5. Through that same point, again, we're still going to start at that point P. So we're going to redot it so we can see it. So my point P is right there. We want to move with our slope of negative 1/5. So we are going to go down 1, right 5. 1, 2, 3, 4, 5. Or I could go up 1 and left 5. 1, 2, 3, 4, 5, and go this way. 3, 4, 5. Either way is fine. I can go either direction as long as we are being careful and making sure we calculate our slope tidily. Kind of like that. We're going to do one more set of graphs, and that'll be where we stop. Because sometimes we'll be given just our slopes, sometimes we'll be given a point and a slope, sometimes we'll be given a whole equation to graph. And we're going to remember how to do that, and that'll be our last part for today. And then tomorrow, we'll keep working with 3-3. Need more time on this page? Everybody need more time on this page? Okay. So sometimes we'll just be given straight up equations. Here we've got 1 in our slope-intercept form, 1 in our standard form, 1 in our point-slope form. We can do these however we wish. So 2 of these are going to be very, very easy for us to put up here. 1 of them is going to be slightly more challenging. So our first equation here, y equals 2x plus 1, that's in slope-intercept form. Where am I going to start? 1. That is my y-intercept, right on my y-axis, positive 1. Just like we did before, moving with our slope, we've got a slope of 2. We've done that one once already today. We're going to go up 2, right 1. Oop, that's not what I meant. Up 2, right 1. Up 2, right 1. Okay. All our points, we can plot up our line. Get a line that looks kind of like that. That's my purple line. Slope-intercept form we're usually pretty familiar with. How do I graph something in standard form like this? What should I do for this guy? You could find x and y intercepts, figure out where x equals 0, y equals 0. Totally valid. You could put this into slope-intercept form and solve it that way. However you want to go about it. It genuinely does not matter. I feel like a lot of us are going to wind up putting it into slope-intercept form because that's something we're really comfortable with a lot more. In which case you'd wind up with our minus 5y equals minus 2x plus 8. So our y equals 2/5 x minus 8/5. Ew. But workable. Because I can start at my y-intercept of negative 8/5, which is right about there-ish. Gonna be down about here. And I could either go up 2 over 5 to get my line, or I could go up 2/5 over 1. That would also work, and that would get me a lot closer to pieces. And in fact, if I go down 2/5 left 1, I wind up right on an intersection. Going up to right 5 would put me right about here. And a lot of times on these lines, we're estimating. We're getting it as close as we can. If we need graphical perfection, we are going to have a computer do it because we are humans and not robots, and therefore not good at that. The bottom one is our point slope form. So we're going to find the point in it, where my x was -1, my y is a +2, and our slope is 1/2. So we're going to start from our -1, +2, and our slope of 1/2, up 1 over 2. This is our last one for the day, I promise. And we're going to get a line that looks kind of like that. Not quite parallel, but pretty darn close. Tomorrow we're going to work more with our slopes and stuff, but that is all of 3-2 and the start of 3-3.
Oh my god.
I'll put it up, but I think we might get to the end of 3-3 tomorrow.